Hello, you're welcome back. All right, so let's continue from where we stopped. Now, this was the question that I was solving, okay, which I asked you to finish up. So I hope that you did it, okay. So what I'm going to do, I'm going to also solve it in this video so that you can cross-check your answer. All right. So we've already expanded this series. All we just need to do is to simplify it. Okay, let's begin. Let's start from the very first term here. So here I have 2 raised to the power of 6. Okay, so 2 raised to the power of 6 is 64. So the very first term there is going to be 64. Okay, 64 x raised to the power of. Okay, so our answer, the first term is 64 x raised to the power of 6. Okay, let's. So here, let's see what we have here. So this is 2 raised to the power of 5, which is 32. 32 multiplied by 6. So 32 times 6. What do we have? 192. So the next term is 192. Okay, 192 plus 192. Then of course x raised to the power of 5. Let's proceed. Okay, so the next term, let's see what we have. So here we have 6 times 5. Okay, which of course is 30 divided by 2 factorial. 2 factorial of course is 2 times 1, which is 2. 30 divided by 2 is 15. Then don't forget that we'll still have 2 here raised to the power of 4. 2 raised to the power of 4, okay, is 16. So we'll have 16 times 15. 16 times 15, that's what we have here. And of course that is 240. Okay, let me still do that again. This is 6 times 5, which is 30. 30 divided by, okay, divided by 2, that is 15. Then 2 raised to the power of 4 is 16. 16 times 15, that is 240. Okay, so the coefficient of this of the next term is 240. 240, then x raised to the power of 4 plus, let's work on the next term. All right, so here we have it. This is 6 times 5 times 4 divided by 3 factorial. So what I'm going to do is 3 factorial, of course, is 3 times 2, which is 6. So 6 will divide, will cancel the 3 factorial. So I'm left with 5 times 4. Now 5 times 4 is 20. So here, this is 2 raised to the power of 2 raised to the power of 3, which is 8. So of course 20 times 8, that gives me 160. So the coefficient of the next term is 160. Then of course x raised to the power of 3. Okay, so let's go to the next term plus. Here we are. So in this case I'm having 4 factorial. You know very well that this 4 factorial is 4 times 3 times 2. And here I have 4 times 3 already. So this will be cancelled by this. Okay, so the 2 will divide, okay, the 2 will divide the 6 to give me 3. 3 times 5 is 15. Okay, so that was the reason of this 15 here. So now this 15, I'm going to use it to multiply 2 square, which is 4. All right, so 15 of course times 4. Okay, so here that's going to be 60. Okay, so this is going to be 60 x raised to the power of 2. Let's proceed to this particular term. This is 5 factorial. You know that 5 factorial is 5 times 4 times 3 times 2 times 1. So invariably this 5 factorial will cancel the whole of this. So leaving behind 6. So 2 raised to the power 1 is 2 raised to the power of 1 is 2. 2 times 6 is 12. Okay, so this is going to be 12x Then the last but not the least, okay, 6 factorial, we cancel 6 factorial, and of course 2x raised to the power 0 is 1. So the last term is 1. Alright, so cross-check your work. Now in exams, usually you may not be asked to expand the binomial, okay, series. You might be asked to find a particular term in the binomial expansion. So if you are being asked to find a particular term in a binomial expansion, you don't need to perform this expansion. All this thing that we did here, you don't need to do it, okay? So let's look at how you can find arrow, okay, a particular term. I won't call it nth term since I'm using n to be the power of our binomial expansion, okay? So the arrow term of our expansion. So let's use our of course binomial expansion of a plus b raised to the power n, the one we use to derive, okay, our general formula. So now you notice one thing in this expansion, the very first term is n combination 0, not n combination 1, then a raised to the power of n, then b raised to the power of 0. Then the second term, instead of being this n combination 2, is n combination 1. So you now discover that this particular number here, all right, is always 1 less than that term. Okay, this term is 1, but what I have here is 0. This term is 2, but what I have is 1. Okay, so this is gonna be n combination 1. You know that already. Then a raised to the power n minus 1, then of course b raised to the power 1. So generally, to find the any number of term, okay, so the arrow term of an expansion is given as n combination, r is the term, but the r is being reduced by 1, r minus 1, okay. They will now have a raised to the power of n, okay, raised to the power of n, then minus a is reducing, okay, so it will be reducing by whatever you have here, minus bracket open r minus 1. So it will be reducing by the same, okay, the same value, and the b will be increasing by that same value, okay. The term minus 1. So this is actually the general formula for finding a particular nth term or rth term of the expansion. Okay, now let's prove this particular formula. Let's prove the formula. So what you have to do, you write it somewhere. Now let's use this expansion right here. Okay, now let's say I want to find the fourth term of this expansion. This is 1, 2, 3, 4. This is the fourth term of the expansion. Okay, so let's see whether this formula is valid. So the fourth term is going to be n, of course, n is 6, combination 4 minus 1, which of course is 3. Okay, combination 4 minus 1, which is 3. Then we a raised to the power n. Our a of this expansion, remember the expansion was 2x plus 1, so our a is 2x. So that's going to be, of course, 2x raised to the power of n minus 1, that is 2x raised to the power 6 minus 3. N minus, that is 2x raised to the power of n minus, okay, r minus 1, okay, minus whatever you see here, all right, at this subscript. So that's going to be 6 minus 3. Then of course our b is 1, okay, multiply by 1 raised to the power of the same thing that we see here, okay, 3. So here we go. So this is going to be equal to 6 combination 3. Then of course 2x raised to the power of 3. then multiply by 1 raised to the power of 3. I think that's exactly what it is for this that term. Okay, yes, that's exactly what it is. So but in this case I wrote it in terms of combination. So I wrote it in terms of combination. So it's just for you to evaluate it. All right, evaluate this combination. Of course, you know what this combination is. 6 combination 3. That is, of course, 6 factorial divided by 6 minus 3 factorial times 3 factorial. Then, of course, 2x raised to the power of 3, then multiply by 1. Okay, let's see what we have here. So this is 6 factorial. This is going to be 6 times 5 times 4. Okay. Then do you know what? I'm going to stop at 6 minus 3 factorial, because 6 minus 3 factorial will give me 3 factorial. So I'll stop at 3 factorial so that the 3 factorial at the denominator will definitely cancel out. So this is going to be times 2 raised to the power 3. Of course, that is 8. Then, of course, x raised to the power of 3. So let's work on this. This cancels this. This, of course, is 3 factorial. Okay, so as a matter of fact, so 3 factorial is 6. So 6 will cancel the 6. So I'm left with 4. 4 times 5 times 4, right? Which of course is 20. Okay. So that's going to be 20 times 8. Was it what I got? Let's go to that. Okay, the fourth term again. Yeah, here's the fourth term. 1, 2, 3, 4. Okay. Yes, this is was. So this is what's supposed to be. Let me see. If you're on the same, if it is so that's going to be 8. Yes, 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 yes. 5 times 4, 20. Yes. So that's 20 times 8, and that's exactly what, unless I made a mistake in that calculation, then I can correct it. So this is, of course, is still 5 times 4. That is what I calculated, which of course is 20. Then 2 raised to the power of 3 is 80. So I hope the calculation I did was correct. Let me do that again. That was still supposed to be, as a matter of fact, 20. So this is supposed to be 20. All right, then multiply by 8. That's what I'm supposed to have there. So I hope, okay, 160. Yes, it was correct. And what I got was 160. Let's see. Was it 160 I got? Yes, that's what I got. Okay, so as a matter of fact, it's correct. This is 20 then times 8, which is 160. 160 x raised to the power of 3. So that is it. So it's either you write it in terms of the combination, or you can actually use expand the combination for this the third term. Remember, if you don't want to apply combination, all you just need to do for the coefficient is going to be n. Since it's the third term, that's going to be n into n minus 1, then n minus 2. Okay, so that's this particular n factorial is going to have 3 factors, 1, 2, 3, because that is the third term. Okay, that is of course the combination is n combination 3. Okay, so as a matter of fact, then you divide by 3 factorial, then multiply by whatever you have. So any method that you actually didn't fit, the one that is very convenient, so you can actually apply the combination, work on the combination, or you apply this. Okay, so let me apply that. Okay, let's I don't want to work with the combination and combination R. Okay, so since I'm looking for the fourth term. Okay, I'm looking for the fourth term, then definitely what I'm going to have is n into n minus 1, then n minus 2. Well, I think this one will kind of confuse you because you may not really know the term that you are looking for. Okay, the combination actually help you. This combination actually help you to understand that this particular for this step that you're looking for. Okay, the number here is gonna be the term minus one. So I think go with this so that you will not make mistake. Okay, in your evaluating the coefficient of this of the particular term that you're looking for. So please take note of this. I hope this is well understood. Okay, so we are going to look at a more example. There's another example that I have here. Okay, so this is a question here. We are being asked to find the binomial expansion of the square root. So what we are looking for is the binomial expansion of the square root of 1 minus 3x. Okay, so after that we use it to evaluate the square root of 0.7. Let's expand this first. So 1 minus 3x is the same as 1 minus 3x raised to the power of the square root of 1 minus 3x is the same as 1 minus 3x raised to the power raised to the power of half. Please pardon me. Square root is always raised to the power of half. So that's what we are expanding. So we are expanding 1 minus 3x all raised to the power of half. So applying the formula, you know what it's going to be. Okay, so this is going to be 1 raised to the power of half, which is t1. Then of course plus, okay, the next term is going to be the coefficient is n, right? And the n is half. Okay, so then 1 raised to the power of n minus, okay, so the coefficient of 1 reduces by 1, but I don't need to write it because 1 raised to the power of any power is still 1. Okay, so I don't even need to write the 1, so I'm only going to focus on this particular term. All right, so let's see what we have. So this is going to be 3x, okay, then of course raised to the power of 1. Now it's not replace, you have to also, you don't have to ignore the negative sign because this is not just 3x, this is minus 3x. Okay, the negative sign is really very important for you to include. If it was positive, I don't have to bother, but now it's a negative sign. All right, the 3x is negative, so that's minus 3x. Okay, so minus 3x, of course, raised to the power of 1. Okay, remember the power of 3x is increasing while the power of 1 is decreasing. Okay, so here we go, plus the next time, you know what is going to be, that is n bracket open n minus 1 divided by 2 factorial. Okay, then of course minus 3x raised to the power of 2. Okay, so let's proceed now. This will definitely it's going to be continuous because I will never get to a point where 1, okay, will actually reach half. Okay, so it is an infinite series, as a matter of fact. So let's proceed. So we're going to stop it somewhere after some number of terms. Okay, so we'll go next. This is going to be half bracket opened into half minus 1, then another bracket half minus 2, then this time around divided by 3 factorial, then minus 3x raised to the power of, this is 3s, this was 3s raised to the power 2, then definitely this is going to be 3s raised to the power 3. So I can stop it here because it will continue that way. Okay, because as I keep on going, I can never get to half because I've already passed half. All right, so I cannot get to half. All right, so here we go. At this point, we can evaluate. So this is going to be 1. Okay, of course, this term right here is negative, so it will affect this positive sign. So that's going to be minus 3x raised power 1. Okay, so that's going to be minus 3 all over 2, of course, x. Then for this one, this is half minus 1 is going to give us minus half. Minus half multiplied by half, that is minus 1 all over 4. This is minus 1 all over 4. Then, of course, divided by 2 factorial. If I divide by 2 factorial, 2 factorial is 2 times 1, so that's going to be times 2 here. Okay, then minus 3x. Okay, minus 3x squared. 3 square is 9. That's times 9. Okay, then of course s square. So I hope that is well understood. Okay, then plus, let's see what we have in this case. So this is this is minus 1 all over 2. This is also minus 1 all over 2. Minus 1 all over 2 times minus 1 all over 2, that's going to give me plus 1 all over 4. Plus 1 all over 4 multiplied by 1 all over 2, that's going to give me 1 all over 8. So 1 all over 8 divided by 3 factorial, that's going to be 1 all over 8 times 3 factorial is 6. Okay. Then of course, this right here, if I work on it, minus 3 square is going to give me minus 27. Of course, then x raised to the power of 3. So, as I said, I'm stopping there. Let's simplify it. 1 minus 3 all over 2x. 3 all over 2 x. Of course, here this minus will definitely affect this plus. So this will give me, okay, will it affect it? No, there was no minus there. Where did I get the minus from? Okay. Let's see what was it minus? Let me see that. This was minus 1 all over 2 minus 1 over, okay, that was minus there, so it will definitely affect this plus. So that's going to be minus 9s squared divided by 8. Okay, let's see what we have here. Of course, this minus will still affect this. So this is going to be minus 27, then 8 times 6. 8 times 6, 48. Okay, so 27 all over 48, then x raised to the power of 3 plus dot is infinite. Square root is always infinite. The series of a square root is always infinite. Okay, so that's why when you evaluate the square root of a solid, you have some decimal numbers to show that it is continuous. Okay, continuous to infinity. So this is the binomial expansion. Now the question actually asks us to use this binomial expansion to evaluate the square root of 0.7. So we are using this expansion to evaluate the square root of 0.7. So I'm going to express this in terms of the binomial 1 minus 3x all raised to the power of half. This is equivalent to, okay, this is equivalent to what I have here. So just for me to express this into, okay, so to express 0.7 into what I have here, what I would do is simply Okay, I will just equate 1 point minus 3x equal to 0.7 to know exactly what x will be. Okay, so if I do that, so this is gonna give me, if I arrange the equation, okay, so I move this to this side, so this is gonna be 1 minus 0.7 is equal to 3x. So this is okay, 1 minus 0.7 is equal to 3x. So invariably this is 1 minus 0.7 is 0.3 equal to 3x. So with what I have here now, I'll have it that if I make x the subject, s is going to be equal to 0.3 divided by 3, which is equal 0.1. So x is 0.1. So if that be the case now, we can now use this. So square root of 0.7 is the same as bracket opened, okay, 1 minus 3, okay, because this is 1 minus 3, then multiply by x, which of course is 0.1. So the x is 0.1, then I'm raising it to the power of half. So, which of course is going to be, which I'm going to use this binomial expansion to evaluate. Okay, so, you know, this is in the binomial expansion, what we have was 1 minus 3x raised to the power of half. So any place I'm seeing x now, I'm going to insert 0.1 to it. So let's go to the expansion. So I will clean up. So I'll go, let's go to the expansion. So using this expansion now, our x is 0.1. So that simply means that the square root of 0.7 is using this expansion, this is going to be 1 minus 3 all over 2, then x is 0.1 minus 9 all over 8, x is 0.1 square minus 27 all over 48, x is 0.1 cube. Okay, so let's see what we have. So this is going to be 1 minus 0.3 divided by 2. That should be 0.15, if I'm not mistaken. Okay, 0.3 divided by 2, 0.15. So this is 0.15. Then minus, this is 0.9 divided by, oh, this is 0.9 square, 0.09, okay, divided by 8. So this is meant to be 0.09 divided by 8, 0.01125, 0.01125. Then the last but not the least, minus 0.3, 0.1 cube, 0.1 cube. Okay, so that should be 0.1 cube is 0.001. Okay, 0.001, 0.001. Then I multiply that by 27, then divide it by 48. So that's going to be 0.0005625. 0.000, okay, 5625. So let's add everything together. So at the end of the day, this is going to be 1 minus 0.15 minus 0.01125, then minus 0.0001, 5625. All right, so approximately what you are having here is 0.83818. 0.83818. Okay, so I hope that's one. So even if there's a mistake somewhere in our expansion, what is important is the steps are right correct. So just for you to cross check if in our calculation if we made a mistake in any of this calculation. All right, so that is it for this video. We are going to look at more in this next video. So see you in the next video. Thank you very much.